now we'll see what is circular, another list called a circular linked list. Circular linked list. Okay, so here, as it say, in circle you cannot find which is a starting point, which is an ending point, right? The same way, the circular linked list in which the last node contains a pointer to the first node of the list. Okay, so we also have circular doubly linked list. Okay, right? So what we are going to see now is a circular singly linked list. Okay, so while traversing a linked list, right, we can begin at any node and traverse a list in any direction. Okay, the forward or backward until we reach the same node where we started. Thus, a circular linked list has no beginning and no ending. Okay, so which means we can traverse the list, okay, from any node to any other node in any direction. Okay, so which means forward or backward direction. Okay, right? So we reach the same node where we started. We reach the same node where we started. Okay, it has no beginning and no end. Let me just take the linked list that we already seen. Now we'll see how we can represent. Okay, assume that this is the last node. Okay, so you will not have a null in any node. Okay, I have to draw this right, otherwise you don't understand. Okay, so this is how the single linked list works. Circular single linked list works. Okay, so why do you want to go for the circular linked list? Okay, we widely use this in operating system. Okay, for the task maintenance. Okay, so now suppose you are surfing internet. Okay, so you want to use a back button and forward button to move to the previous pages. Okay, which we already visited. How this is possible? This is a circular linked list is used to maintain the sequence, right? The sequence of the web page that we have visited. Okay, so you can press the forward button, it will take you to the front page. If you press the backward button, it will take you to the back page. So this can be done using the circular queue. So in the same way, we can traverse a list, okay, until we find the next entry that contains the address of the first node. Okay, this denotes that the end of the linked list. So the node that contains address of the first node is actually the last node of the list. So when we traverse the value, right, and the next pointer, we'll finally see, right, the linked list, right. So there are two different way of circular linked list can be uh, maintained, and in which we insert a data, right. So here we insert a data at the beginning or at the end. Okay, so how do we find the data? How do we find the circular linked list uh, is having the last node? So the node which is having the address of the first node is called the last node. Okay, so how do we do that? So how do you find the address of the next as the last node? Suppose if the pointer of next is the pointer of next is a start node means then that node is called the last node. Okay, so whatever we have seen inside at the beginning, so here additionally what you have to do is, so you have to find the last node first and then you have to insert the data. Okay, right. So this is the additional thing that you have to do when compared with the single linked list. Okay, so we have to traverse till the 23. Okay, whose next node is the head. Okay, which means this is the last node. This is how I can find. Okay, when I insert an element in this fashion, right, so what do I do? Okay, so I just suppose if you want to insert one more data, right, so insert data as 13. So what I have to do, I have to make so this is the existing one, so this is a new node, so we have to create a new node as usually, new node malloc of size of start of node. Okay, create it and then find traverse until whose next is start or head, right. So just go towards it and then make a link to the pointer. Okay, so make the link to the pointer. So I have to traverse until 23 using ptr. Whose the ptr I'll check while ptr of next is equal to start. Okay, right, while ptr of next is start, then I can find that that is the last node. So how will I traverse it? Whenever the ptr of next is not equal to start, please move the pointer. Okay, when it is equal to start, right, then make a new node of next as the start node and the ptr of next is equal to new node, and then set that new node as the start node. Okay, so let me just write the algorithm for this. So number one, create new node. Assume that we created a linked list. Okay, circular linked list. So inserting a data at first. So okay, create a new node, and then check the pointer is equal to pointer is head, right? And while pointer of next is not equal to head, okay, move pointer is equal to pointer is equal to pointer of next. If it is not head, just move it. What happened if it is head? Okay, what happens if it is a head? So we have to make the new node next as head. Okay, next has head, and then pointer of pointer of next is equal to new node, which means, so next I have to create a link for here as well, right? So this creating a hindrance. So assume that it's a link. Okay, so node of next is equal to head. That is what we have done, right? So and now the pointer is pointing to here. So the pointer of next is the new node. That's what I mean. So this is where the pointer. Okay, I have to move the pointer from here to here. If it is not equal to, if whose next is not a start. So this next is also not a start. This next is also not a start. This next is what start. Okay. So now the ptr of next is equal to new node. That's why this is a ptr, and its next is the new node. Got it? Okay. And then node is equal to head at last. Okay. So this is what the algorithm for inserting element into the circular linked list at first. Same way for deleting as well. So you can write, think, and develop an algorithm by keeping this as a reference. Okay. Next we have a doubly linked list. So doubly linked list means you can, so here you have to move only forward. If I want to go both the forward and backward, I have to use what? Circular doubly linked list. So there you will find a two arrow, right? Okay. So before that you need to see what is doubly linked list. Okay, so there you will have two arrows for it. So what is doubly linked list? So what is doubly linked list? So as I told you, it will be having a forward pointer and backward pointer. Okay, the entire structure is different. It's a two-way linked list. Okay, two-way linked list is a more is a more complex type of linked list which contains a pointer to the next as well as the previous node in the sequence. Okay, so it consists of data part. Next, it consists of address to the next pointer. Then address to the previous pointer. Okay, so how it looks like. So let me just make it as fine. Okay, so as we create, yeah, fine. So next we need to create an arrow. So here, if you edit text, text, right? Okay, so here let me represent it as null. Okay, and this is going to be a data 23, and this is the address of the next pointer, right? And here this one, here it is data 67, and it will be null because it's a last node, right? So last node will be null. Okay, so if I increase the size, it will be better. Fine. Okay. So here the starting node will have no backward link, and the last node will not have any forward link. So which means that is the last node. So the node which is having the next node as a null node is the last node. The node which is having the previous link as a null is the first node. Okay. And here you can simply have anything. Uh, just add a text. Just add 45. Okay. And add 56. Okay, so this is just a forward link. Now we have to draw the backward link as well. Okay, so this is what double linked list. So if you see the data structure here in C, so we have to write a program like struct node struct self-referential pointer of star f link, which means a forward link, and int data, then struct node star b link. Okay, so once you've done this, it will create something like this. Okay, so as usual we need to initialize the f link as null, and I mean we have to create a node. Okay, the structure also ends with what, semicolon, right? So you'll create a node 1 whose first f link is null, and create a node 2 whose b link is the next 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 pointer. Okay, right? So likewise you can create a doubly linked list. Okay, right? So that's what I told you, right? So it is used for keep track of the sequence. Okay, so it also has its own algorithm, but we have doubly linked list. So once you know, right, the single linked list and doubly linked list is nothing to you. So you can create the same way we created a single linked list. Just you're going to add one more structure, and you're going to initialize the f link as null, and then at last, okay, who's the last node b link will be the last node f link will be null, and the first node b link will be null. Okay, in a doubly linked list. So this is how we can create a doubly linked list in data structure. Let's see. Let's just copy this. Okay, and then open new one. So let's see uh, how to create this right linked list, doubly linked list. So as usual, I've taken the same program. Okay, so I'm going to give it as struct data, so struct node f link, and this is going to be, okay, let me yeah, okay, b link, right? So initially the struct node is star link, so it creates me the um, link, and this is a star. Fine. Okay, it is done. It is done. Next is what? One new node is not required. We're not going to create anything. We need a pointer. We don't need a temp or previous pointer. This is not required. Okay, so we are allocating the same allocating memory, and this is not required. This too is not required, right? And now we are going to link the each node. Okay, how to link the each node? One node next is equal to 2. It is not x next here. It is going to be a f link. In the same way, f link, right? And what's the next of f link? It's a null. Next f link of 3 is what? Null, because that is a last node. Next, what I have to do? I have to do same one backward link we have to create now. So this is b link. One b link is what? Null. Then the two the 2's b link is equal to what? 1. And 3's b link is equal to 2. Right? So this is for forwarding link, this is for backward link. Okay, so this is forward linking, and then backward linking of each node. This is done, this is done. Okay, and now this is pointing to the first one, and this is not required. So here is pointing to the first one, and this is also not required, and this is also not required. Now we are going to just see, instead of next it is going to be f link. We have to move the, so f link. So that's the end of the while loop this time. Okay, so save it as doubly linked list. Let's check whether we have done it properly or not. So what it says, expect data. So it's supposed to be 120. Yes, we have got it. Right now, if I want to print in reverse, right now I'm going to use a B link. Instead of it as 1, I'm going to give it as 3. Okay, instead of F link, I'm going to give it as a B link. Now you see it'll print in reverse. Okay, backward link. First 67 is printed, then 22, then 1. Okay, so this is what W link list. Okay, the implementation of the W link list, right? Hope it makes sense. So we have seen what is linked list, right? And what are the operations that we are going to do with the linked list, right? It's a base, right? So it's one of the data structure which uses a pointer. Okay, we're not going to implement anything in the array. So we are implementing using the pointer, the self-referential pointer, which is used to create the same kind of node. Okay, right? So if you see a linked list, right, it has double linked list, circular linked list. Okay, what problem the circular linked list solves? Because you can start from any node, but in single linked list you have to start from the first node. Okay, but what's the thing in what's the thing in a single linked list? You have to visit every node, whether you require or not. Suppose if you're searching, so in our case, 122, 67, you would reach 67, you have to pass through 1 and then 22. Okay, so you have to go in a sequential way, right? You should not go in the random way as we go in an array, right? So it's a sequential axis, right? So, and what problem that double linked list solves? It helps you to move forward and backward. Whereas in single linked list, I can go only forward, not backward. So using double linked list, I can move forward and backward. Okay, double is circular, right? So double is circular will solve the problem of moving from here to there. Here to there means what? From starting node to ending node. Okay, without beginning and ending. Okay, so this is how the single linked list works and double linked list works. Now we are going to see how we can make use of the linked list. Okay, to implement stack